Hi everyone, welcome back to Tech Data Engineer. So, if you're a data engineer working on GCP and your BigQuery cost is going out of control, or your Spark job are wasting CPU, memory, and shuffle, then this video is for you. Okay, because I'm making this video for optimizing the cost in GCP basically. I'll take the use case from GCP. Okay, so this will be very useful. Okay, I'll take the two scenarios where BigQuery is scanning too much data and Spark Job wasting CPU, memory, and shuffle. So because of this problem, how we can optimize the cost of the GCP. Okay. So I'll explain why BigQuery scan too much data and how Spark Job silently burn money, and most importantly, real productions techniques to reduce the cost by 50 to 70%. Okay. So let's get started. Have you ever checked your GCP billing dashboard and got shocked by your BigQuery bill? Okay, or you noticed your Spark jobs run fine, but still cost a lot CPU, memory, and support. Okay, so I'm making video based on that. Okay, based on the real problem, I'm making video. So I have taken two scenarios here, where BigQuery is scanning too much of data and Spark job wasting CPU, memory, and shuffle. Okay, so now let's start with the first cases. Okay, so where the problem is BigQuery is scanning too much of data, and because of that, you are getting more charged. Okay, so let us understand first the warehouse. Storage cost versus query cost. Okay, so every time I'll take the example of a GCP related things. Okay, component, BigQuery, data prep. Okay, so let us understand the BigQuery cost model. So BigQuery has two major component. Okay. So BigQuery has two major cost. Okay. So one is the storage cost and other is the query cost. Okay. So storage cost like how much data we store, active versus long-term storage. So in this case, cost is bit low. Okay, coming to query cost. So query cost is the big problem. So that charged per TB scan. Okay, so if you are writing a query and how much data is getting scanned because of your query, either you are writing optimized or you are writing optimized query or without optimized optimizations. So whatever the data is getting scanned, that is the charged per TB scan. Okay, this is why your 90% of money is wasted. So what is the key rule when you are looking for your BigQuery things? So BigQuery is cheap to store data but expensive to scan data. Okay, so let us understand with a scenario. Suppose we have a table size 5 TB. I'm just taking a simple example. So if you understand this, you will understand the real thing scenario also. Okay, so suppose your table size is 5 TB and you are writing the query like select a star from cells. Okay, so from cells table you are taking the data and seeing the report. So in this scenario, what will happen? BigQuery scan all your 5 TB of data. Okay, so if your 5 TB of data is getting scanned, then you will getting charged for this all entire 5 TB. Okay, but how to write your optimized query? So you can write like select order ID or revenue from sales where order date is something like you wanted to only the order ID versus revenue for date 1/12/2025. So you don't have to write the query. So this query also give this result, but this is the optimized query. You have to write like that. So if you will write like this. So in this case, scans only the required column plus partitions. So this is the partitions and this is the required column. Okay. So you have to write the optimized query. Whatever the column need, whatever the partitions need, you have to do that. So that cost drops drastically if you write the optimized query. Okay. So this is the one scenario. Now let us understand the partitions pruning scenario. Okay. So what is partitions pruning? Okay. So BigQuery skips partitions that are not required for the query. Okay. So, so BigQuery always skips partitions that are not required for your query. So let us understand with the example. Suppose we have a partitions table with order date with a partitions table. So we have partitions data like 2020 partitions have 2 TB, 2024 2 TB, 2025 1 TB. Okay. So if we are writing some query like without partitions filter, suppose I am writing a select sum of revenue, I am adding the revenue from the sales. So if you are writing like this, it will scan the entire 5 TB of your data. Okay. So this is without partitions. You are writing the sum of revenue from sales. Okay, that is scanning 5 TB, and based on that, you are getting the result. So with partitions filter, if you are writing like select sum of revenue from sales where order date is itna. So only for this date, if you wanted this, instead of writing this query, you can write like this. So what is this? So first, here it is the filter. So here there is a filter. So based on this filter, so based on this filter, it is scanning only the required thing. So it is scanning only for one date. It is going first on 2025 partitions, and based on that only ordering, only filtering the 2025 12 1. So it is scanning approximately 3 to 5 GB. Okay, because I am just writing this figure because I have taken this scenario, and I have just calculated the scanning and things and all. So earlier it was scanning 5 TB, and now it is scanning approximately 3 to 5 GB. So that is the cost reduction of 95%. So see, if you are using the partitions and partitions tuning, then in this case you are optimizing the cost by 95%. Okay. So that is the one of the scenario where you have to use partitions. Okay. Now, so always use partitions by date, and use mandatory partitions filter, and avoid where date equals to timestamp column because it breaks the pruning. Okay, so it breaks the pruning. That's why we have to use timestamps column only. Okay. Now let us see some case with the materialized view also. So what is materialized view? And materialized view and why we are using. So what is materialized view? So that is nothing but it is a pre-computed result. Okay, so stored for BigQuery. So you are writing some query and that getting stored, and every time it is getting auto refresh. Okay, instead of writing the query again and again, you are just storing somewhere, and it is just auto refreshing. That is called materialized view. But that is basically a pre-computed result stored by BigQuery. So instead of recalculating, select country or sum of revenue from sales, group by country. So group by country wise, it is giving the sum of revenue. Okay, and so so BigQuery, what it will do, it will store the result and once and it auto refresh it. Okay. So let us take an example use case where we have to create a dashboard that runs same query every 5 minutes. So if you are using without materialized view, so what will happen? Query scan GB repeatedly. Okay. So if you are writing this query every time, so what will happen? Query scans and every time GB of data got a scan. So because of that, you are getting high cost. Okay. If we are using materialized view, so what will happen? Query hits the cache result because it is already saved in BigQuery. So what will happen? You have to pay almost zero scan cost for that because that is the materialized view. But the problem is you can't use every time the materialized view. So you have to see the scenario in which scenario you are using that. So when there is a aggregation is there, okay, if there is aggregation is there, if there is a dashboard and the dashboard is refreshing after some interval of time, or if you're using you are making a use case where there is a repetitive queries. So in case of repetitive queries also you can use that materialized view, or if there is a filtered or grouped data are there, you can that in that scenario also you can use materialized view. Okay. So because of materialized view, because of partitions, we are saving the storage cost versus optimized cost. So we are like handling the first scenario of like storage cost versus query cost. Okay. Now let us understand the next thing, data retentions policy. So in case of so what is the problem with that? So most companies stores the log forever, old unused data or duplicate history. Okay. So because of that, what will happen? Y- and companies are not setting the expiration. So so this is so this data is there for long interval of time, and you are not using that data, because of that it is charging. It is charging like that there is the extra burden on the storage cost of the GCP. So what will happen? You have to seed the BigQuery table expirations. Okay, like auto delete functionality, auto delete old partitions and all. So let us see example here. So if you are writing alter table sales set options partitions expiration date equals to 180 days. So what it will do? It will automatically it will alter the table until the partitions expiration date. We have set it the 180 days. It will alter the table sales, and it will like it will do the auto delete. Okay, auto delete the old partition. So there are two scenario. If our things are less than 90 days, it is active storage, and if it is more 90 days, it is long-term storage. So that is the based on this scenario also you can see this storage cost. So storage cost drops automatically if you are using that less data or less scan cost. Okay. So in this scenario, we are reducing the cost also. Like if you are setting the, or to suppose you are taking the snapshot of a data, and every time you are running your job, and your job is like doing the multiple scans out of the table, so you have to set the expiration time so that every time, every some interval of time, your previous data got deleted. Okay, so that is one of the uh, way to reduce your optimized cost, your cost of the your BigQuery. Okay. Now see the other scenario where we are seeing the Spark cost optimization, like data proc, data flow, or Spark on GCP. Okay. So that is the biggest Spark cost killer. So if we have the what is the biggest Spark cost killer? If we have too much supples, too many small files or wrong partitions. So what is so how to optimizing? So these are the problem we have. Like too much files is there, then that is a problem. Too much small files are there, that is the overhead of that system and input output. And if there is a wrong partitions counts are there, then that is also the problem. In case of Spark cost optimization things. So how to design the system? So for that we have the how to optimizing the suffer. So I'll explain two scenario. One is the bad Spark design and one is the optimized approach. So in bad optimized like bad Spark design, what we will do? We will do the df dot group by user ID and dot count. So if we'll do for each user ID, we are doing the group by. So that is the massive shuffle in your data. So if you have huge data, then that is a massive shuffle. Sometimes it will break because of this this shuffling issue. Okay, and you are doing the for user ID if you are doing the account. So that is a massive shuffle, and for network and these explorations also. So that will cause sometimes problem. So what is the optimized approach in that case? So optimized approach is you have to filter it early, like df dot filter, only filter the date which date you wanted the data. Like I wanted data on this date and select the user ID, like for which user ID they wanted. So select the user ID, that to group by user ID and dot count. So if we'll do this, it will filter the data. Okay, it will filter the data. So what will happen? In that case, filter early, then reduce the column and use the broadcast join. Okay, so and use the broadcast join. So if we will do this way, then it will reduce the our optimizations. Like it will reduce the shuffling also. It reduce shuffling because of filter, because of reduced column, and because of broadcast join. We are reducing our shuffling. So that is the optimized approach in case of shuffle. Okay. Uh, then we have the scenario like repartitions versus coulage. So what is repartitions do? So repartitions always increase or rebalance the partitions. Okay. And what coulage do? Coulage do always reduce the partitions, no shuffle. Okay. In case of coulage, there is no shuffle. So if we are doing df dot coulage 50, so what we are doing? We are reducing the executor cost, executor usage and cost. Okay. So that way we can optimize our Spark things. Okay. Then other thing is we have to consider the right file size for Parquet. Okay, so every time we have to choose Parquet because I have already explained our system design concept, why to use columnar storage, and Parquet and ORC is the example of columnar storage. So you are getting data in some different format, you have to change in Parquet and then you have to do the optimizations or BigQuery related things. Okay. So why 512 MB? So because BigQuery and Spark perform best when. So always you have to think. You don't have to don't have to make your file size is too long or too small. Because if you are making too large, then that is very difficult, and if you're making too small, that is the overburden. Like there is overhead for that. Okay. So what you have to do? So BigQuery and Spark perform best when you have your file are large enough, like reduce metadata, but not too large, because if you are making too large, there is the parallelism loss also will happen in that case. So you have to make your file size something like between 128 to 1 GB. Okay. So let us see the bad design. So if you are making like a 10 millions file with 5 MB, that is the huge metadata overhead, because for each file you have to keep the storage of metadata, and slow read also will happen because of input output operation. Okay. So what is the best practice you have to do? You have to make a file size between 128 MB to 1 GB. So that's why I'm just keeping here ideal size is 512 MB. Parquet file is the like ideal file size. Okay. So, okay. So, what will happen? What is the GCP impact happen? So, faster BigQuery external table queries, faster Spark query, lower CPU or input output cost. If you make this ideal file size, then this will be the happen in the GCP impact. Okay, and that is the reducing the our cost is. Okay. So if I wanted to summarize these things based on these two scenarios, so how to reduce the BigQuery cost? You always use partitions or mandatory filters before writing the query. Select only the required column. Okay. So select only the required column. Always use materialized view. Okay. And delete old data if it is not required. How you will delete? You have to make the retention policies. Okay. Always use avoid select star. Instead of avoid select star, what you can use? You can use that. You have to select the particular column if it is required. Always use filter. Okay, mandatory filter if it is required. So if we'll do this way, so in this two scenario, whatever I have explained, you will come up with a huge optimization cost. Okay, so BigQuery scanning too much data, that is the one problem, and Spark you're wasting CPU, memory, and shuffle time. So I have explained the solutions and problem also because of these two things. Okay. So if you'll do this way, you will optimize your BigQuery cost. Okay. At certain amount of time, certain percentage. Sorry. Okay. So this way you can optimize your BigQuery cost. Thank you. Thanks for watching.